Welcome to all of you. Now we discuss about MCQ 2021 Calcutta University Mathematics Honors paper CC-3 real analysis. Question paper 2021 paper CC-3 question 1a. Let A equal to the closed interval 0 1 and B is the set of all those elements 1 by n such that n belongs to natural number n, then A minus B is correct option is 3, neither an open nor a closed set. This set A, the closed interval 0 to 1, and B is the elements 1 by n, that is 1, 1 by 2, 1 by 3, 1 by 4, and so on. So A minus B equal to the singleton set 0 and this interval half to 1 union 1 by 3 to half union open interval 1 by 4 to 1 by 3 and union and so on up to infinity. So this infinite union n equal to 1 to infinity open interval 1 by n plus 1 comma 1 by n together with the singleton set 0. Now 0 belongs to the set A minus B, but 0 is not an interior point of the set A because any neighborhood of 0 is not a subset of A minus B, so A minus B is not an open set. Clearly, half is a limit point of the set A minus B, but half does not belong to A minus B, so A minus B is not a closed set. Hence, A minus B is neither an open nor a closed set. Question 1b. Let B equal to the sets 1 by 2n plus 1 by 3m such that n comma m belongs to the set of natural numbers n. Then 1 by 3 is, correct option is 3, both an element and a limit point of the set. Let epsilon greater than 0 by Archimedean property of real number R, there exists a natural number s such that 0 less than 1 by 2s less than epsilon. Then minus epsilon less than 1 by 2s less than epsilon, adding 1 by 3 on these sides. So 1 by 3 minus epsilon less than 1 by 2s plus 1 by 3 less than 1 by 3 plus epsilon. And this shows that epsilon neighborhood of 1 by 3, that is 1 by 3 minus epsilon to 1 by 3 plus epsilon, contains a point 1 by 2s plus 1 by 3 of the set B other than 1 by 3. So by the definition of the limit point, 1 by 3 is a limit point of the set B. Next, take n equal to 3, m equal to 2. Then 1 by 2n plus 1 by 3m equal to 1 by 6 plus 1 by 6 equal to 2 by 6 equal to 1 by 3. Obviously, 1 by 3 belongs to the set B. Hence, the correct option is 3. Both 1 by 3 is both an element and a limit point of the set. Next question C. If A, B are bounded subsets of R such that supremum A less than infimum B, then correct option 2, A intersection B equal to phi. Let supremum A equal to alpha and infimum B equal to beta. Then A belongs to capital A, set A. This implies A is less than equal to alpha. This A alpha is the supremum and this beta is the infimum of B. And by the given condition, supremum A is less than infimum B. So if A belongs to capital A, set A, so obviously A, this small element A, small a is less than equal to alpha. By the definition of supremum, and similarly, by the definition of infimum, if B belongs to the set capital B, then beta is less than equal to B, because beta is the infimum. Thus, A less than equal to alpha, less than beta, less than equal to B. And for A belongs to capital A and B belongs to capital B. Then A less than B for A belongs to capital A and B belongs to capital B. Then A intersection B equals to 5. Correct option is 2. Next question D. The set T is the set of these points, n-tuple points x1, x2, dot dot xn, such that x1, x2, xn belongs to the set 1, 3, 5, 7, 9 is correct option is 2, finite. Now this n-tuple x1, x2, xn is an element of the set T. Then x1 can be chosen in 5 ways from the set 1, 3, 5, 7 and 9. Similarly, we can choose x2, x3, xn 5 way is so T contains 5 into 5 into 5 into 5 in factors, that is 5 to the power n ways. That is the cardinal number of T is the 5 to the power n, which is a finite number. Then for a fixed natural number n, we get a finite set T. That is T contains 5 to the power n elements. So correct option is 2, finite. Next question E. Which of the following statement is true? Correct option is 4. Every uncountable set has a limit point. Now, option 1, every bounded set has a limit point. But it is wrong. This 1, 2 is a bounded set with no limit point. Limit point is 5. So this is bounded set, but limit point, no limit point. Next, option 2, every infinite set has a limit point. This set of all natural numbers is an infinite set with no limit point. So option 2 is also wrong. Option 3, every bounded infinite set has an interior point. This set, this 1 by n, such that n belongs to capital N natural number, this bounded infinite set with no interior point. No interior point. So every bounded infinite set has an interior point. This statement is also wrong. So only the statement 4 is the correct option. Every uncountable set has a limit point. Let proof of this statement, let A be an uncountable set of real numbers. Let n equal to A set A intersection this closed interval minus n comma n. Then A is the infinite union n equal to 1 to infinity an. If every an is countable, then so is A. Hence, some an is uncountable. Thus, A has an uncountable and bounded subset. Therefore, we can assume without any loss of generality that A itself is bounded. Now, by Bolzano-Weierstrass theorem, A has a limit point. Hence, every uncountable set has a limit point. Note that any uncountable set of real number R has uncountably many limit points. So correct option is 4. Every uncountable set has a limit point. Next question F. If 0 less than x less than 2021, then limit n tends to infinity x to the power n plus 1 plus 2021 to the power n plus 1 whole divided by x to the power n plus 2021 to the power n is, correct option is 3, 2021. Now set this 2021 equal to a. Then the given limit n tends to infinity x to the power n plus 1 plus e to the power n plus 1 divided by x to the power n plus e to the power n equal to limit n tends to infinity dividing numerator and denominator by e to the power n plus 1. So we get limit n tends to infinity x by a whole to the power n plus 1 whole divided by x by a to the power n plus 1 into 1 by e. This is equal to a into limit n tends to infinity x by a to the power n plus 1 plus 1 divided by x by a to the power n plus 1. Now 0 less than x less than a, 0 less than x less than a, so 0 less than x by a less than 1, so limit n tends to infinity x by a whole to the power n equals to 0. So a into 0 plus 1 by 0 plus 1 equal to a, because this x by a is less than 1, so x by a whole to the power n plus 1 tends to 0 as n tends to infinity. Hence correct answer is a is 2021, and so correct option is 3, and is 2021 is the answer. Next question G. If xn equal to 1 plus sine bracket n square plus 1 into pi plus cos bracket n cube minus 5 into pi whole divided by n plus 1, then limit supremum xn is the correct option 4, 0. Now first x1, calculate x1. First we calculate x1. This x1 equal to, put n equal to 1. So this 1 plus sine 2 pi plus cos minus 4 pi whole divided by 2. And this equal to 1. x2 equal to 1 plus sine 5 pi plus cos 3 pi whole divided by 3. This is equal to 0. x3 equal to half. x4 equal to 0. x5 equal to 1 by 3. And so on. Now sine n pi equal to 0 for all n belongs to the set of integers z. Cos 2n pi equal to 1 for all n belongs to set of integers z. Cos 2n pi plus pi equal to minus 1 for all n belongs to the set of integers z. Then n cube minus 5, this n cube minus 5 pi, this equal to the sets. This sets n cube minus 5 is minus 4, 3, 22, 59, 120, 211, 338 and so on. So cos n cube minus 5 pi, so this when this even n is even integer minus 4, so this 1. Odd integer 3 when n equal to 2, that is this cos 3 pi, this is minus 1. Even integer 1. 59 minus 1, 1 minus 1, 1 minus 1. And sine n square pi, n square plus 1 into pi is all sequence of 0. So actually xn, this sequence, xn sequence is this 1, 0, half, 0, 1 by 3, 0, 1 by 4, 0 and so on. So there are two subsequences. Number 1 is the even terms x2n minus 1. There's 1, 1 by half, 1 by 3, 1 by 4, 1 by 5, and so on. This tends to 0 as n tends to infinity. And the second subsequence, for even terms, x twice n sequence, this all sequence 0, 0, 0, 0 tends to 0 as n tends to infinity. If the sequences x to n and x to n minus 1 of the sequences x to n converge to the same limit a, then sequence xn is convergent and converges to a. So limit supremum xn equals to 0 equals to the limit infimum xn equals to 0. Actually, this sequence xn converges to 0. So limit supremum, correct answer is this, limit supremum xn equal to 0. So you can write this problem from this part. Just you can start from this part. Xn sequence xn equals to this, and this odd subsequences this tends to 0, and even subsequences this tends to 0, and this. But this first part only for your explanation to yourself, but not necessary to show in this calculation. Next question. Identify the incorrect statement from the following. 3. Option 3. Unbounded sequence cannot have any subsequential limit. This is the incorrect statement. Note that this incorrect statement. So all 1, 2, and 4 are all correct statements, but this 3 is the incorrect statement. Unbounded sequence cannot have any subsequential limit. Consider the sequence un, where un equals to n to the power minus 1 to the power n into n greater than equal to 1. So this subsequence u twice n minus 1. So when u twice n minus 1 is negative, so n to the power minus n. So when n equal to 1, this 1, n equal to when 2, that is this n equal to 2 means 2 into 2, 4 minus 3, 3. So 3 to the power minus 1 to the power 3 into 3. So this 1 by 3 to the power 3. 1 by 5 to the power 5, 1 by 7 to the power 7, and so on. This tends to 0 as n tends to infinity. And for even subsequences, this u twice m, this 2 square, 4 square, 4 to the power 4, 6 to the power 6, 8 to the power 8, and so on. This tends to infinity. So clearly, this sequence un is unbounded sequence, and the subsequence u twice n minus 1 of un is convergent and converges to 0. So an unbounded sequence may have a subsequential limit. So the incorrect statement is 3. You may choose this type of sequence, this sequence 0, 1, 0, 2, 3, yes, 0, 3, 0, and so on. Dot. This sequence, this for odd terms 0, and for even terms this 1, 2, 3, 4, and so on. So this sequence is unbounded sequence, but for this odd terms 0, 0, 0, 0, so subsequential limit this tends to 0 for this subsequential limit 0. So unbounded sequence, this type of sequence, unbounded sequence, but subsequential limit 0. So incorrect option this. Next question. Let an sequence n be a sequence of positive integers and bounded by a positive integer k, and then the series n equal to 1 to infinity n whole divided by k plus 1 whole to the power n. Correct option is 1, must be convergent. Now, 0 less than n less than equal to k for all n belongs to capital N set of natural numbers, and k being a fixed positive integer by the given condition. Then this implies n by k plus 1 whole to the power n less than equal to k by k plus 1 whole to the power n for all n belongs to set of natural numbers n. Now 0 less than 1 by k plus 1 less than 1. This implies summation n equal to 1 to infinity 1 by k plus 1 whole to the power is convergent, because by this geometric series the sum, infinite sum, the series n is convergent if mod of a, modulus of a less than 1, and divergent if modulus of a is greater than equal to 1. Since 1 by k plus 1 is less than 1, so this series 1 by k plus 1 whole to the power n is convergent. And then series k by k plus 1 whole to the power n is also convergent for some positive integer k. So from 1, by comparison test, we get this right hand side series is convergent, then this less than portion left hand side must be convergent. So by the comparison test first type, this summation n equal to 1 to infinity n by k plus 1 whole to the power n must be convergent. Next question, J. The series summation n equal to 1 to infinity 2n square whole divided by 1 plus n square. Correct option 3, diverges. Because we have a theorem, a necessary condition for the convergence of a series summation n equal to 1 to infinity un is limit n tends to infinity, n tends to infinity un this equal to 0. But the converse of this theorem is not true. So this limit n tends to infinity 2n square by 1 plus n square equal to limit n tends to infinity 2 by 1 plus 1 plus 1 by n square equal to 2 is not equal to 0. Hence the given series diverges. So by this theorem, we can write this series un converges implies limit n tends to infinity un equal to 0. But this limit un n tends to infinity equal to 0 does not imply this series un converges. And contrapositively, we can say if limit un n tends to infinity not equal to 0, this implies series un diverges. Thank you for watching this video. This completes the MCQ paper CC-3 2021.